Greetings, amazing students. Welcome to another lesson from iCampSA. In this lesson, we're going to be doing a past paper question. This particular paper is from Gauteng province, and it was written in November 2021. Okay, so the area of focus is trigonometry and trigonometric functions. Let's get into it. Okay, for question 4, hopefully it's visible. Using the we're given the diagram there that you see there. In that diagram, what do we have? We have the length of the terminal arm, which is 2 units, and I would guess this is the length of the x coordinates for the terminal arm. As the length of the x coordinates, which is √3. Okay, so what we don't have is the y there. The value of y is what we lack in this particular equation. Okay, so here, using the diagram above and without the use of a calculator, determine the value of sine theta. Okay, so we don't have the y value, and you know that for sine theta we have to use the opposite over the hypotenuse side. That's the ratio. If you remember the soccer tower, you know, so soccer tower. So it's soccer tower. I say the sine trigonometric ratio, opposite over hypotenuse, cos adjacent over hypotenuse, tan opposite over adjacent. So for sine theta we have to use what? The opposite side, which is this one, over the hypotenuse side, but we don't have the opposite side, which is y. So we have to start by using the Pythagoras theorem to determine the value of y. So for 4.1.1, we have to say y squared is equal to r squared minus x squared. Okay, what is r squared? The hypotenuse side is 2, so we're gonna have 2 squared minus what is x squared is √3 squared. This is y squared, therefore y squared is equal to 4 minus what is √3 squared is going to be 3. So 4 minus 3 is going to be 1. Let's introduce a square root on both sides. Positive and a negative root, positive and a negative root. So therefore y is equal to 1 or y is equal to -1. Let's see which one is correct. The arm is on the first quadrant where y and x are both positive, so this one is the correct one. Y cannot be equal to 1. Y cannot be equal to 1, so we know that the value of y now is 1, the opposite side. Okay, so for sine theta, what is sine theta? Sine theta, therefore for sine theta, which is equal to y over r, sine theta is going to be 1 over what is r? R is 2, so it's 1 over 2. That is the value of sine theta. Okay, then next I'll have to determine the value of sine theta cos theta. 4.1.2. So for 4.1.2 we have to determine the value of sine theta cos theta. Sine theta, we say it's what? Sine theta is the opposite, y over r, and then multiply by cos theta, the adjacent, x over r. Okay, so what is y theta? We've already calculated sine theta. Actually it's gonna be 1 over 2 multiplied by what is cos theta, x over the adjacent side is √3 over 2. So we're gonna have √3 over 2. Then let's simplify this. 1 multiplied by √3, that is gonna be √3. 2 multiplied by 2, that is gonna be 4. Therefore the answer is gonna be √3 over 4, and that is your final answer. Okay, then let's come here. Next, let me see if I can. I think I have to add a page here. Let's quickly add a page. for this particular question. Yeah, and the reason why I'm adding a page is because I want to, so we can see what we are talking about. To copy this, come here, I paste it, then I drop. Yeah, so we are in 4.2 now. 4.2. Okay, so 4.2, if x is equal to 60 degrees and y is equal to 45 degrees, determine the value of the following without the use of the calculator. 60 degrees and 45 degrees, what are those? Those are our special angles, those are our special angles. Let's see. Okay, so for this one, we haven't constructed what you call this thing. We haven't constructed the triangles for our special angles, but let's quickly construct those. For those of you who may not remember, how do we actually go about determining our special angles? So we have two special triangles, the right angle triangle that we use. The first one, it has angles, let me use a different color, of 45 degrees and 45 degrees and 1 unit here. Then we calculate the third side using the Pythagoras theorem. You will get that it is root 2. It is root 2. Okay, and then the other triangle, we have to draw an equilateral triangle. So a triangle with 3 equal sides and 3 equal angles. Then the angles are gonna be what? 60 degrees. And then before we put the third angle there, the third one, we have to draw a line. We will call it line AB from the third point, and it's perpendicular to the third side, so it bisects the third side. So it cuts it into 2 equal parts, so it basically just bisects the triangle. So we're gonna have one side equal, these two sides will be equal to each other, and also the angles there will be bisected. So instead of 60, we're gonna have 30 degrees and 30 degrees angle there. Let's call this line AB, and this equilateral triangle has side, all the sides are equal to 2 units, so it's gonna be 2, and then we're gonna have 1 and 1. Remember that for the third side, 1 plus 1 is what? Is 2, but I just put 1 and 1 because the side has been bisected, or it has been cut into 2 equal parts. Okay, once we are here, what do we need next? What we need is to find the third side. So to find the third side, we can pick any triangle, because now it's the right angle triangle. You can use the Pythagoras theorem to determine side AB. So for side AB, we're gonna say AB squared is equal to the hypotenuse side, which is 2 squared, minus the adjacent side, if we may say, which is 1 squared. Okay, so we're gonna have 2 squared is what? Is 4 minus 1 squared, which is 4 minus 1 is gonna be 3. Therefore AB is equal to what? Root 3. Therefore this third side here is gonna be root 3. Once we are here, we can actually use our special angles now to simplify the expressions that we have there. So we are given 1 over 2 sine 2y. Let me rewrite that. We have 1 over 2 sine 2y, 1 over 2 sine 2y, minus open bracket 2 tan, I think it's squared, it's 2 tan squared x over 2, half angle x over 2. Okay, close brackets multiplied by cos, close brackets, let's shift this, we multiply by cos, then cos x, and this is what we have to actually simplify. And remember that x is 60 degrees. Let me write it here. X is equal to 60 degrees, and the other one, y, is equal to 45 degrees, and y is equal to 45 degrees. Okay, let's go ahead and solve this one. So 1 over 2 sine 2y. What is 2y? What is our y angle? For so for 2y is 2 times 45. So we're gonna have 2 times 45 degrees, close bracket, minus 2 into tan squared x. What is our x? X is 60 degrees divided by 2. 60 degrees divided by 2. Multiply by cos x. X is 60 degrees, so close this bracket here. Multiply by cos x. For these two brackets, let me use a different color. Okay, so once we are here, let's work with what is inside the brackets first. So we're gonna have 1 over 2 sine of, what is 2 times 45? That is gonna be 90. So it's sine 90 minus 2 multiplied by tan squared 60 over 2. What is 60 over 2? That's gonna be 30. So we're gonna have 2 tan squared 30 degrees. So this one is in brackets, multiplied by cos x, cos 60 degrees, cos 60 degrees. Okay, so 90. So we have it's three special angles that we deal with in grade 10. That is 30, 45, and 60. But also 90 and 0, they are special angles. They are special angles, just like sine of 90. Sine of 90 will always be equal to what? Will always be equal to 1. It will always be equal to 1. And then cos of 90 becomes 0. It becomes 0. Cos of 90 is become 0. So for sine 90, it's just equal to 1. That's a special angle. So here we're going to have 1 over 2 sine 90, which is 1 minus 2 into tan squared 30. What is tan of 30 degrees? Let's come here. We have this 30 degrees. Tan, remember, according to SOHCAHTOA, is what is opposite over adjacent. So the opposite side of this angle, let's just focus on one triangle. This one, we'll focus on that triangle, the yellow one. Then I just draw there. So tan 30 is opposite. The opposite side to 30 degrees is going to be this one, which is 1 over adjacent, which is root 3. So tan 30, we're going to have 2 multiplied by, why did I put it outside of the bracket? 2 into, what is tan of 30? We said it's going to be 1 over root 3, opposites over adjacent, 1 over root 3, close bracket, squared, close bracket, squared, multiplied by cos 60. Cos 60 adjacent, what is the side adjacent to 60 degrees? Is that 1 of 1 unit, 1 over hypotenuse, 1 over 2. So cos 60 is 1 over 2. Okay, let's work. 1 over 2 multiplied by 1, we're just going to have 1 over 2 minus 1 over root 3 squared is going to be, this is going to be 2 into 1 over 3, because root 3 squared is 3. Close brackets, multiplied by half, multiplied by half. This 2 will cancel. This 2 will be left with 1 over 2 minus 1 over 3. So we'll be left with 1 over 2 minus 1 over 3. 1 over 2 minus 1 over 3. Just to show each step. So a half minus a third, this is going to be equal to, we have to find the common denominator, which is 6. Lowest common denominator is 6. So 2 into 6, it goes 3 times. So we're going to have 3 minus 3 into 6, it goes 2 times. We're going to have 2. So 3 minus 2 is going to be 1 over 6. So the final answer here is what? Is 1 over 6. That is your final answer there. Okay, this one quite has a few steps, 1 over 6, but that is your answer, and it's 6 marks. That is how you go about answering that. Then let's come here to 4.3. Okay, let me copy this one again and then also add a page again. Let's bring this one here and this one there. Okay, so we are now in 4.3. Let's put the page here. And then we dropped, we have just done 4.2. Now we are in 4.3. So 4.3, determine the acute angle beta to 2 decimal places. So acute angle is the angle that is less than 90 degrees. For 4.3.1, we have sine beta minus 17.8 degrees is equal to 0.215. Let's solve for this. Okay, first thing first, remember when we are dealing with these equations, what is within the brackets here, we treat this as just one angle. So when we transpose, you're not gonna be now taking that 17/8 to the other side without taking the sine first. So first thing first, we take sine to the other side, so we're gonna be left with beta minus 17.8 degrees is equal to, when you take sine to the other side, we have to use the second function, so we're going to have sine inverse of 0.215. Beta is equal to sine inverse of 0.215. And then we take the, what is this? That is 12.416 plus 17.8 degrees. 8 degrees. Therefore, beta is going to be what? It's going to be 30.22 degrees to 2 decimal places. Yes, and that is your final answer, and it is an acute angle as they have told us. Okay, and then next we have to determine tan 3 beta is equal to root 3 for 4.3.2. we have to determine beta in that equation. So we have tan 3 beta is equal to root 3 Okay, first thing first, we have to take the tan to the other side. We're gonna be left with 3 beta is equal to tan inverse root 3, and therefore the next step here, we divide by 3 on both sides. This 3 will cancel this one, and therefore beta will be equal to, we have to put this one in the calculator. So tan inverse of root 3 over 3 is 20 degrees. Beta is 20 degrees in this equation. Let's go to 4.3.3. we have 3 sine beta over 2. So for 4.3.3 we have 3 sine beta over 2 sine beta over 2 is equal to 2.012 is equal to 2.012. Double check. Yes. Okay, first thing first, we have to divide by 3 on both sides. This 3 will cancel this one, therefore we're gonna be left with sine half beta over 2 is equal to 2.012 over 3. Then next step, we take the sine to the other side. We'll be left with beta over 2 is equal to sine inverse over 2.012 over 3. Okay, and then next multiply by 2 on both sides. Therefore beta is equal to 2 multiplied by sine inverse of 2.012 divided by 3 Okay, and then beta is going to be equal to, you punch this in your calculator, 2 multiplied by sine inverse of 2.012 over 3, and this one gives us 84.24 degrees. 84.24 degrees. 84.24 degrees. And that is that for 4.3. Let's go ahead and do 4.4. Let's see. Okay, we still have a space. I just need to copy this. Okay, let me do it like this. Paste. And at this point we just need 4.4. Let's come here. So determine the expression without using a calculator. So once again, once we are told not to use a calculator, that means you're gonna have to use special angles. So we have tan 30 degrees multiplied by cosec 60 degrees over cot 45 degrees multiplied by sine squared 45 degrees. So first step, let's change the reciprocals, because we have two reciprocals, which is cosec and cot, and cosec is the reciprocal of sine and cot is the reciprocal of what? Of tan. So this expression is essentially equal to, this is equal to tan 30 degrees multiplied by 1, it's gonna be 30 degrees multiplied by 1 over sine 60 degrees brackets all over, what is cot? The reciprocal of cot is gonna be 1 over tan 45 degrees, put it in bracket, multiplied by sine squared 45 degrees, sine squared 45 degrees. Okay, might have to add a page here. Okay, so what is tan 30 degrees? We already have our special triangles. Tan 30 is opposite over adjacent, so it's 1 over root 3. For tan 30, this is equal to 1 over root 3. It's 1 over root 3, close brackets, multiplied by 1 divided by, what is sine 60? Sine 60 is opposite, let's come to our triangle. Sine 60 is opposite root 3 over hypotenuse 2, so it's root 3 over 2. Root 3 over 2. This one is going to be root 3 over 2, close bracket, over okay, what am I doing? Over, let me shift this one to here, over 1 over tan 45, 1, so it's gonna say 1 divided by, what is tan 45? Let's come to our triangle. Tan 45 is opposite is 1 over adjacent, so tan 45 is just 1 divided by 1, so it's just 1, multiplied by sine squared 45. So sine 45 is what? It's opposite over hypotenuse, so it's just gonna be root 1 over root 2. Let's take this angle, the opposite side is 1 over root 2. 1 over root 2. Okay, so we're gonna have 1 over root 2 squared. over root 2 squared. Okay, now it's just simplifying the fractions. We have 1 divided by root 3, 1 divided by root 3 multiplied by 1 divided by root 3 over 2. This one is going to change to 2 over root 3. 2 over root 3 over 1 divided by 1 is just 1 multiplied by on the low we're going to have 1 divided by 1 is 1, so it's not going to make any difference. 1 divided by root 2 squared is going to be 1 over 2. This is going to be 1 over 2. Okay, and then let's work the numerator. 1 over root 3 multiplied by 2 over root 3. 1 multiplied by 2 is going to be 2. Root 3 multiplied by root 3 is going to be 3. And then this is divided by 1 over 2 in the bottom. We're going to change this one to 2 over 3 multiplied by 2, of which will give us 4 over 3. 4 over 3. And that is your answer. That is your answer. 4 over 3. Okay. Yeah, it's done. 4 marks, 4.4. That is how you will work that one. Special angles and work with functions. Let's go to question 5. Question 5. So question 5, 5.1. The following are given. Okay, the following are given. Let's see something. I think I should let's do it like this. Copy. Did I just cut instead of copy? Copy. Question 5, we'll put it here. The copy, because I only want to be left with 5.1 for that. It's at 6 marks, so I guess we'll have to refer a lot. So we drop this one out, just focus on 5.1. Okay, so for 5.1, the following are given. 7 sine x is equal to 4. 7 sine x is equal to 4. Where x is less than 90 degrees. So what do they tell us? What are they telling us if they're saying x is 90 degrees? They're telling that x, the angle x, is found in what? Is found in the first quadrant, because that is where acute angles are found. And tan y is equal to t. X and y are complementary angles. X and y are complementary angles. So determine the value of t squared without the use of a calculator and with the aid of a sketch. Let's start by sketching what we are given. So what we are given. So we have, first thing first, we have 7 sine x being equal to 4. That is 7 sine x being equal to 4, which means sine x is equal to 4 over 7. And we know that sine x, what is sine x? Sine x is the ratio of sine x is opposites over the hypotenuse side, so it's y over r basically. So in other words, sine x is equal to, let's put this one in brackets, sine x is equal to opposite over adjacent, or y over r. Y over r. Put it in brackets, shift it a bit. So we come here, we have that information, and we are told that x is what? X is less than 90 degrees. So it means that x will be found, that's put 0 degrees, 90 degrees. Let's label our Cartesian plane 90 degrees, 180 degrees, and then shift it a bit. Shift it a bit, 270 degrees and 360 degrees. Okay, it means that the terminal arm will now be found in the first quadrant because theta is less than 90 degrees. Okay, that's the terminal arm. And what is the length of the terminal arm? Since the terminal arm is opposite over hypotenuse, why did I write adjacent? Over hypotenuse. That is our r. What is our r here? Is 7. Our r is 7. Therefore, we're going to have 7. And then since sine x is 4 over 7, that means this side is also 4. The opposite. What is the unknown here? The unknown is the x side. We can use the Pythagoras theorem to determine the value of x. So x here, okay, I don't, yeah, it's the adjacent side. I'm thinking of using x since this is actually dx, angle x, not angle theta. But the adjacent side, not the angle here. I'll just say, I'll call it adjacent. Let's calculate the length of the adjacent side. We have to use the Pythagoras theorem. So the adjacent side squared is equal to 7 squared using Pythagoras theorem minus 4 squared. 7 squared, what is 7 squared? 7 squared is 49 minus 16. That would give us the adjacent side. So adjacent side, what is 49 minus 16? I think that is 49 minus 16. That is 33. Therefore, the adjacent side is going to be root 33. Root 33. That's the adjacent side. So let's put the value here. Gonna have root 33. Okay, now that we have that, we have to determine the value of t squared. Oh, another important information. They've told us that y and x are complementary angles. Complementary angles, they add to 90 degrees. Add up to 90 degrees. That is what is meant by complementary angles. If if x and y are complementary, that means the angle here is y, because x plus y is 90 degrees. Okay, and what do we know about complementary angles? Complementary angles, it means that cos x is equal to sine y, and sine x is equal to cos y. That is the truth about the complementary angles. Okay, and then next we are given that tan y is equal to t. So what is t? If tan y, this tan is equal to t, tan is opposite over adjacent. Opposite over adjacent. So tan y is equal to t. Tan y is equal to t. Opposite over adjacent. Okay. Tan y is equal to t. Okay. Then let's come here. What are we looking for? We're looking for t squared. For t squared, let's come here. We have tan y being equal to t. So instead of working with tan y, instead let's change tan. We know that tan theta is equal to what? Sine theta over cos theta. You remember that identity. Tan theta is equal to sine theta over cos theta. Therefore, we can say tan y is equal to sine y is equal to sine y over cos y. So yes, over cos y. Okay, over cos y. But then we know that sine y, what is sine y? We know that sine y is equal to what? Sine y is equal to cos x. Cos x. What is cos x? Cos x is gonna be okay, let me put the equal signs here. So we say sine y is equal to cos x. So we can say this is gonna be cos x over, but we also know that cos y is equal to what? Cos y is equal to sine x. Cos y is equal to sine x. So therefore we can say over sine x. Therefore this is gonna be what? Let's put it here. Cos x. What is cos x? Cos x adjacent over hypotenuse is root 33 over 7. We have root 33 over 7 divided by sine x, which is 4 over 7 divided by 4 over 7 divided by 4 over 7. Okay, by 4 over 7. Therefore this is what? The 7 will cancel the 7. Therefore we're going to have root 33 over 7 multiplied by 7 over 4. That is how we change the division sign to the multiplication sign. The 7 will cancel the 7, and therefore root 33 over 4. What is this? This is actually tan y. This is tan y all along. Keep track. This is tan y, tan y, tan y, tan y, tan y. Therefore tan y is equal to what? Is equal to root 33 over 4. But we know that tan y is equal to what? Tan y is equal to t. So in other words, this is the value of t. So this is also equal to t. Okay, so t is equal to root 33 over 4. Therefore, we can now say, therefore, t squared is equal to what? Is equal to root 33 over 4 squared, because t is equal to root 33 over 4. So this one is going to be what? What is root 33 squared? It's going to be 33 over what is 4 squared is 16. 4 squared is 16. That is t squared. T squared. Okay. So that is your answer. 33 over 16. Includes a bit of work, but it's 6 months, so it's 6 marks, so it makes sense. That was our question 5. That is how you will go about doing that. Will help you use complementary angles, your understanding of complementary angles, and the trigonometric identity of tan theta being equal to sine theta over cos theta, and the Pythagoras theorem. 6 marks. Okay. So we are still in question 5. Let's do now drop 5.2.2 going down. Assume that sine square x plus cos square x is equal to 1. This is an identity that sine square x plus cos square x is equal to 1 for all values of x. Now simplify the following expression. 5.2.1. 5.2.1. we are told, first thing first, sine squared theta plus cos squared theta is equal to 1. That's an identity. Let's put it in bracket, or they use x instead of theta. X. Okay, and then we have to simplify 1 minus cos squared x minus sine squared x. Then we come here, 1 minus sine squared, it's cos squared x minus sine squared x. 1 minus cos squared x minus sine squared x. Okay, so for this one, I'm gonna say this is equal to 1. Let's take out the common factor of the negative 1. So we're gonna have minus, open brackets, we're gonna be left with cos squared x plus sine squared x. But we know that cos squared x plus sine squared x is equal to what? Is equal to 1. This we are back to here to the identity, so we can just substitute that by 1. So we're gonna say 1 minus 1, of which is 0. That is your answer there for 5.2.1. 5.2.1. 5.2.2 cos squared x plus tan x multiplied by cos x plus sine squared x. Okay, so 5.2.2. 5.2.2, we have cos squared x plus tan x plus tan x multiplied by cot x plus sine squared x plus sine squared x. Okay, let me add a page here. Let me add a page. Okay, so first thing first, we must realize that now we have cos squared x plus sine squared x. What is cos squared x plus sine squared x? Is this identity that we have there, which is equal to 1. So first thing first, those two, this will be equal to cos squared x. Let's put it in one side. Cos squared x plus sine squared x plus tan x multiply, what is cot x? Cot x is 1 over tan x, 1 over tan x. So therefore here we're going to have cos squared x, this is equal to 1. So we're going to have 1 plus tan x divided by tan x is going to be 1. So here the answer is 2. The answer is going to be 2. That's your answer there, 2. And then 5.3, copy 5.3. We are dealing with angles of elevation and angles of depression. Specifically, these are angles of depression that we have there. And remember that the angle of depression top equal to the angles of elevation, alternating angles. So in other words, this angle here is also 34, corner is also 34.4 degrees, alternating angles, and this angle here is also 26.2 degrees. Okay, from the top of the lighthouse, 55 meters above sea level, 55 meters above sea level. So the sea level is where the boats are located. So it's 55 meters above sea level. That tells us what? It tells us that the height of ES is 55 meters. Okay, above sea level. Two boats, M and H, sailing due east, have angles of depression of 26.2 degrees and 34.4 degrees as shown. 34.4 degrees as shown. Okay, calculate distance between the two boats. So first thing first, you have to notice what I've already identified for you, that those angles. So angle, let me just say angle, this is 5.3. 5.3. For 5.3, angle M, the angle M in S or in EM, angle MS is equal to 34.4 degrees. 34.4 degrees. Reason being, these are alternating angles. These are alternating angles. First thing first, angle of depression and angle of elevation. You can also put that definition there. We'll see angle of depression equal to angle of elevation is equal to the angle of elevation. Okay, and then we also said angle H, the angle H of EHS, the angle H of EHS is equal to 26.2 degrees. 26.2 degrees. And side ES, we have been told that it is 55 meters above sea level. We also calculate the distance between the two points, so the distance MH. In order to calculate the distance MH, what do we have to do? We have to separate these two triangles. First thing first, we have this smaller triangle here, that one, with the angle 34.4 degrees, and then we have the larger triangle. But first thing first, let's calculate SM, because we have a side and the angle, and these are both right angle triangles. So we have a side and an angle, there we can calculate side SM, of which is adjacent to the angle. You can calculate side SM, this side, which is adjacent to the angle of 34. So we have adjacent and the opposite side. So which trigonometric ratio we're going to use? It is the tan trigonometric ratio. So we say tan 34.4 degrees is equal to opposite over adjacent is equal to side ES over adjacent, which is SM. Okay, let's make SM the subject, is what we are looking for. So SM is equal to, what is side ES? It's 55 meters, so it's going to be 55 meters divided by tan 34.4 degrees divided by tan 34.4 degrees. And then next, so we basically have side SM now. Now that we have side SM, let's go to the bigger triangle and calculate side SH. Side SH in this triangle now. In this triangle, side SH. Okay, with the angle there of 26.2 degrees. So we have opposite side and the adjacent side. We are looking for side SH. So we're going to use the tangent. So we say tan 26.2 degrees is equal to opposite. What's the opposite? It's 55. Opposite is the side ES. Here it is 55. So let's start by saying it's ES over the adjacent side is SH. SH. We make SH the subject. We're going to have SH is equal to, what is ES? ES is 55 meters divided by tan 26.2 degrees. Tan 26.2 degrees. Okay, and then once we are here, let's add a page. Once we are here, now we have side SH. We have side SH, they complete this side, this entire side, and then we have side SM. We need what? The distance between the two points. We need side MH. So in order to calculate side MH, we're gonna say SH minus MH, or we're gonna say SH minus SM. So for what? For MH, the side MH is equal to the whole side, which is SH, the whole side, which is SH, minus what's the other side? SM, minus SM. So therefore MH, what is SH? The side SH is 55 over tan 26.2 minus SM. What is SM? 55 over tan 34.4. That's 55 over tan 34.4, and this is equal to what? 55 over tan 26.2. You punch this in your calculator, minus 55 over tan 34.4. This is gonna be 31.45. 1.45 meters, and that is the distance between the two boats. That is the distance between the two boats. Okay, 5.3. That is how you'll go about calculating the distance between the two boats. Okay, let's go to question 6. Okay, so for question 6, we are now dealing with trigonometric functions. The diagram below represents the graphs of f at x is equal to a sine x, which one? From the shape we can see that this is the graph of f, it is also mentioned there, and g at x is equal to b cos x. This is the graph of cosine. So for x is the element of 0 degrees to 360 degrees. So the range, for the domain is 0 to 360 degrees for this what's it called, for these graphs, for both of these graphs. So for 6.1, write down the values of a and b, the coefficients of sine and cos. So a is the distance from the baseline to the maximum or the minimum point, both with the negative and the positive sign. So let's start with a. For the sine theta, what's the maximum point here? The maximum point is 2. So the value of a will be the distance from the baseline of the function here to the maximum point. What's that? To the minimum point, since our graph starts on the beginning, or it has been flipped. So the value of a is that distance, of which is what? -2. Both we take it with the sign. So for 6.1, we're gonna say a is equal to -2, and then b is the distance from the baseline of the function to the maximum or the minimum point. It depends on which side we start with. We start here on the positive side, so the maximum point is 1 there. This line is our baseline for the function, so the value of b is going to be what? It's going to be 1. So we say b is equal to 1. b is equal to 1. Okay, and then for 6.2, for which values of x will j be a decreasing function? Remember that how do we see a decreasing function? A decreasing function is a function that as the values of x are increasing, the values of y are decreasing. So we come to our function here. As we're going this side, remember that the values of x are increasing, but the values of y are decreasing. We start from 1 to 0, but when we go from 0 to 9, as you see that as we increase the values of x, the values of y are decreasing. So this function will be decreasing all along, up until here we reach that stationary point, and you start to see that as we increase the values of x, the function starts to increasing. So it's from 0 to 180 degrees. It's for those values of x that function of g will be increasing, the cosine function. So for 6.2, I'm gonna say where x, okay, let's put it here, where x is greater or equal to 0 degrees, but x is less or equal to 180. We have to just say where x is greater than 0 degrees but less than 180 degrees, because at 180 degrees the function is stationary. It is neither decreasing or increasing. That's a stationary point. So yeah, and also there at 0. Okay, and then next, what is the amplitude of f? The amplitude of f, So the amplitude is equal to the value of A, but the amplitude is always positive, so if A is -2, the amplitude will just be 2, A positive 2, because the amplitude is always positive. So for 6.3, the amplitude is, say the amplitude is equal to amplitude of what? Of F is equal to 2, positive. What is the range of G? To determine the range, we look at the maximum, which is 1, the maximum point of G, which is 1, and then the minimum, which is -1. So the function of G, it ranges between those 2 points, -1 and 1. So we say the range of G for 6.4, the range, looking at the y values, y is the element from -1 to +1. That's the minimum and the maximum is. And then next, for 6.5, for which values of x is f at x minus g at x is equal to 2. For which values of x is f at x? What is f at x? F at x is the sine function, is this one. So that function minus g at x equal to 2. Let's start there at 90. At 90, f at x is what? Is -2, and g at x is what? Is 0. So -2 minus 0 is what? Is -2. Then we continue, but when we get there to 270, we see f at x being 2, and g at x being 0. So 2 minus 0 is going to be what? It's going to be 2. So it's where x is equal to 270 degrees. 270 degrees. So we say where x is equal to 270 degrees. Let me double check something. Yeah, so it's those values, where x is equal to 270 degrees, and I don't see any other value. I don't know why it's 2 marks, but yeah, basically that is how you will go about answering these questions. This, I think, marks the end of today's lesson, and if you need to take our classes, you are more than welcome, and you can reach us on this number, which is +27 067 690 4778. Okay, you can contact us on WhatsApp or give us a call. Okay, 067 690 4778. Okay, so that's that +27, there's the area code, South African area code, this one here. Okay, so anyway, this is the end of today's session. Until we meet again, I wish you all good luck and good studies.